Hey folks, welcome to Chapter 4, Section 2, Angles of Triangles. In this video, we're going to be solving for missing angles in a triangle with the knowledge that the sum of the angles in any triangle is 180 degrees, okay? So if you haven't committed that to memory yet, commit that to memory now. All the angles in a triangle add up to 180 degrees, whether it's an acute triangle, an obtuse triangle, equiangular, scalene, isosceles, equilateral, whatever. It's all going to add up to 180 degrees. So here I have some examples, and we're going to figure out the measures of each missing angle. So let's start with this one right here. So I think the easiest one, well, I mean, we could go in numerical order, but I think the easiest one to get right now is angle 2. 57 plus 71 is going to be 128 degrees. And so angle 2 is going to equal 180 minus 128, which is going to be 52 degrees. Okay? So let's turn our attention to angle 1 now. Angle 1 is a linear pair with angle 57. How do you know it's a linear pair? It's on a straight angle, and then it's just being cut by this line right there. So yeah, these are adjacent angles here. So angle 1 is just going to equal 180 minus 57, which is going to equal 123 degrees. And so if angle 1 is 123, and then we also know that this is 28 degrees, then angle 3 will equal 180 minus 123 and 28, which is going to equal 29 degrees. And so, yeah, that's everything on this first triangle right here. So this next triangle has a bunch of triangles in one, right? So let's see here. What I'd like to do first is I like to look, is there any triangle with two angles given? And yeah, angle 7, it has two angles that are given inside that triangle. So I'll do 180 minus 58 and 65. That's going to give me 57 degrees for angle 7. Next, if you look at it, angle 7 is a vertical angle with angle 5. So that means they have to be congruent angles. So if angle 7 equals angle 5, then angle 5 also equals 57 degrees. There, rewrote it a little bit. But so now we know that this is 57 and this is 67. So angle 4 must be 180 minus 57 and 67. That'll give me 56 degrees for angle 4. So now I want to turn my attention to figure out the angles in this triangle right here. So this one's may look a little tricky, but if you look at it, this is a straight angle right here, right? This line. So that means angles 6 and 7 form a linear pair. You could also look at it from this perspective. This is also a straight angle or a straight line. So 5 and 6 make a linear pair. But remember, 5 and 7 are the same angle, right? So what I'm trying to get at here is that angle 6 plus angle 5 or angle 7, whichever one you're looking at, is going to equal 180 degrees. So just do 180 minus the angle measure of angle 7 or 6 or 5, I mean. So 180 minus 57 is going to equal angle 6. So that means it's going to equal 123 degrees. All right. So we have 123 degrees for angle 6. And so angle 8 and angle 9 are measured or are marked as congruent angles. So that means they are the same measure, right? So we know angle 6 is 123. So if we do 180 minus 123, we'll get 57 because we just said 180 minus 57 is 123, right? So angle 8 and angle 9 got to add up to 57, and they're the same angle. So basically what I'm saying is do 57 divided by 2. That's going to give you 28.5 degrees. And so that's going to equal angle 8, and 28.5 degrees is also going to be angle 9. And so, I mean, think about it. Add those two together, they'll equal 57. Add 57 to 123, they equal 180. So, yeah, this is all the missing angles for this triangle. So looking at the last image of example 1, I have this rectangle with some triangles inside. And looking at angle 1, I see it has a 90-degree angle and 52 degrees right there. So for angle 1, I'm going to do 180 minus 90 minus 52. That's going to give me 38 degrees. So next I'll look at angle 2. Angle 2 has a 90-degree angle and a 38-degree angle. So I'm going to do 180 minus 90 and 38. So that's going to give me 52 degrees for angle 2. And now I'll turn my attention to angle 3 and 4. So what I know here is that this is going to be a right angle at the bottom. And then I know that angle 2 is 52 degrees. And I know that 2 and 3 together make a right angle. See, it's marked right here, but you have this angle cutting into it. So angle 3 is just going to be 90 degrees minus the measure of angle 2, which was 52. So angle 3 is going to equal 38 degrees. And then you got a couple different ways of figuring out angle 4. For starters, if you have a right angle here, here, and here, but not marked here, well, you have a right angle marked in 3 of the 4 corners of this rectangle. So it's at this point, it's safe to assume that all 4 angles are going to be right angles. Because there's no way this can not be a right angle with the other 3 being right angles. So you could do, take the angle measure of angle 1, that's 38, and do 90 minus 38 and get 52. But if you want to like play it safe, quote unquote, like let's say you don't know that this is a right angle, well, now you know that this is 90, and now you know this is 38. So if you do angle 4 is 180 minus 90 minus 38, you still get 52. So that just kind of further proves my point that this is definitely a right angle right here. But that being said, we just figured out all the missing angles on this one. So let's turn our attention to the exterior angle theorem. The exterior angle theorem states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 remote interior angles. So in this example here, the measure of angle A, that means right up here in this corner, and the measure of angle B down here will equal the measure of angle 1 on the outside. Okay, if you were to continue this angle. So not inside the triangle right there. It's not saying angle C equals A plus B. That's not what it's saying at all. So you just take these 2 angles here, and then what's outside of angle C for angle 1. So using that, we have angle 1 here. And so all I need to do is add together 90 plus 40, which is just 130 degrees. So that's what angle 1 is. The reason why this thing works is because if you were to figure out that this angle right here, you would do 180 minus 90 minus 40. That would be 50 degrees, right? And then you would do the linear pair, right? 180 minus 50 degrees is 130 degrees. So with this property, it just does it quicker. You just add together these 2 angles there to figure out this outside angle over there. So in this example, I'm going to go backwards. I know this is 112, I know this is 32, but I don't know the other one. But if you know that this plus this equals 112, then 112 minus 32 will equal angle 2, which is going to be 80 degrees. And so that's all there is to say for that one. And just realized I did my numbering wrong. It's a very small detail, but this was example 1, and then I wrote example 3 here. So my numbering's a little off, but no big deal. Just thought I'd point it out if you're observant and you noticed that. So in the real example 3, find the measure of JKL. So here we have this woman doing this yoga pose. And so we know that x plus 50 will equal 2x minus 15. So that's how it's going to set up. So what you'll want to do is get your x's on one side and get your constants on the other side. So I see that x is smaller than 2x, so I'm going to choose to minus x over to that right hand side. So I get 50 equals 2x minus x is x, so x minus 15. And so now I'll want to add the 15 over to the other side. And then since I just have an x over on the right hand side, I figured it out. 15 plus 50 is 65. So 65 equals x. So we just figured out this angle measure right here. So how do we figure out the outside one? Just plug in 65. So what is 2 times 65? That's going to be 130 minus 15. That'll be 115 degrees. And then you could always check your work because this angle plus that angle should also equal what this angle is, which is 115. So does 65 plus 50 equal 115? Yes, it does. So there you go. There's example 3. In example 4, we're going to find the measures of angle J and angle K. So we're going to add together 2x minus 11 plus 2x plus 27, and then we'll equal it to 100. Alright, so let's add together our like terms. So we have 2x plus 2x, so that's going to give me 4x. And then we have negative 11 plus 27, so that's going to give me positive 16. So I'll write plus 16 equals 100. So the next thing I'll need to do is minus 16 to the other side. On 100 minus 16 is going to give me 84. So I'm going to write 4x equals 84. And then remember, get rid of a number by the letter by dividing it. So divide both sides by 4. And that's going to give me 21. So x equals 21. So all I have to do now is just plug it in. So I'll go alphabetical order here. I'll do angle J first. So angle J is going to equal 2 times 21 plus 27. So 2 times 21 is 42, plus 27 is going to be 68 degrees. Or not 68, 69 degrees. My bad. So now I'll turn my attention to angle K. And so angle K will equal 2 times 21, which is 42. 42 minus 11 will be 31 degrees. And so, yeah, you can always check your work by doing 69 plus 31. That equals 100, and that's what it should equal there. So an alternate way of figuring out like the second missing angle is once I figure out angle J is 69, you could do just 100 minus 69 and figure out that angle K is 31. But, you know, when in doubt, just plug in your value for X, and you'll definitely get the same answer, assuming you didn't make any mistakes earlier, you know. So I hope this video was helpful. This is my last example, so thank you for watching, and goodbye.